Okay, so this is the last lesson of this chapter. So it's chapter 9 on probability and lesson 7, which is on independent and dependent events. More specifically, what we'll be learning today is to find the probability of independent events and to find the probability of dependent events. And then, obviously, our vocabulary is independent events and dependent events. Now, we're going to go over the probability of independent events, and I'll go over the vocabulary term, we'll go over some examples, and then we'll move into dependent events. So, independent events. The probability of two independent events can be found by multiplying the probability of the first event and the probability of the second event. So basically what that means is that there are two or more events in which the outcome of one event does not affect the outcome of the other event. So in this case, event A's outcome does not affect outcome B. So this is an example of an independent event. So example 1, one letter tile is selected. As you can see right here, one letter tile is spun and the spinner is spun. What is the probability that both will be a vowel? So we can see that we have a vowel here with E, a vowel here with A, and a vowel with A in the spinner as well. Now we know that through the fundamental counting principle that we can multiply the two outcomes together to find the total. So we know with the letter tiles there are 4, and then with the spinner there are 3. So we know that there's 12 total outcomes. Now, there are only 2 outcomes that contain only vowels. We know that those 2 outcomes are E with the letter tiles and then A with the spinner, because there's only one vowel in the spinners. And then we know that the second outcome is the A with the letter tiles and then the A with the spinner. So that's 2 outcomes out of 12, so it's 2 out of 12, which we can simplify into 1/6. So that the probability that both will be a vowel is 1 out of 6. Now you don't necessarily need to find all of the outcomes using the fundamental counting principle. You can also make a tree diagram. That is totally up to you. Now, another way to do it, to solve this, like we said with the definition of independent events, is that you can multiply the probability of the first event happening by the probability of the second event happening. So for this one, the probability of selecting a vowel with the letter tiles is 2 out of 4, or 1/2. Now the probability of spinning a vowel with this one is 1/3, right? So we know 1/3. So now if we multiply them both together, so we 1/2 times 1/3, we still get 1/6. So either way you find it. So for this one, it was okay to just think about the possibilities and the different outcomes, but later on it's going to make more sense to multiply the two different probabilities together. So now for this one, example 2, which is our last independent event example, and then we'll move into dependent events. So the spinner and the number cube shown are used in a game. What is the probability of a player not spinning blue and then rolling a 3 or 4? So you're asked to find the probability of the spinner not landing on blue and rolling a 3 or 4 on the number cube. The events are independent because spinning the spinner does not affect the outcome of rolling a number cube at all. So now I want you to pause the podcast, try this one on your own, and remember that you can multiply the probability of not landing on blue by the probability of rolling a 3 or a 4 on the number cube. So I first found the probability of each of the events, and the probability of not spinning blue is 4 out of 5 because 4 is the number of ways that you won't be spinning blue, and then 5 is the total possible outcomes because there's 5 different colors. And then the probability of a 3 or a 4, which is 2 is the number of ways to roll a 3 or a 4, and then 6 is the total number of outcomes, which then I simplified into 1/3. I multiplied the probability of not blue, which is 4 out of 5, by the probability of 3 or 4, which is 1/3. Now remember, when we're multiplying fractions, we just multiply across. So 4 times 1 is 4, and 5 times 3 is 15. Now we cannot simplify that, so 4/15 is our answer. Now to be able to check your work, you could make an organized list, a table, or a tree diagram to show the entire sample space if you wanted to check your work. So now moving into dependent events. So if two events, A and B, are dependent, then the probability of both events occurring is the product of the probability of A and the probability of B after A. So that means that the A's outcome affects B in some degree. So that's when two or more events in which the outcome of one event affects the outcome of the other events. So for our first example, and our only example for dependent events, is number 3. There are 4 oranges, 7 bananas, and 5 apples in a fruit basket, which is a total of 16 fruits. So we have 16 fruits total. Ignacio selects a fruit at random, and then Terrence selects a piece of fruit at random. Find the probability that 2 apples are chosen. So since the first piece of fruit that Ignacio picked did not go back into the basket, it changes the probability of picking an apple for Terrence, because now there's not as much fruit in the basket. So the probability that the first piece is an apple, the probability of an apple first would be 5 out of 16, because there's 5 apples and there's 16 total pieces of fruit. Now the probability of the second one being an apple would be now 4, because there's 4 apples left, and now there's only 15 pieces of fruit left. So now we learned that when you have dependent events, you can multiply them together. But it's a little bit different because you need to consider the second event's going to be a little bit different. You really need to think about it. What is being taken away, and how does that change my total number of fruit in this case, or total number of outcomes? So the probability of 2 apples being chosen, we will have to multiply those together, which would be 5 over 16 times 4 over 15. Now, I can simplify this. I'll divide this by 4, which gives me 1, this by 4, which gives me 4, and then I'll divide this by 5, giving me 1, and this by 5, giving me 3, which will then give me a total of, when we just multiply across for fractions, 1 times 1 is 1, and 4 times 3 is 12. So the probability that 2 apples are chosen is 1 out of 12. So make sure that we're taking notes, writing down questions if we have any. We will be going over independent and dependent events in class. And if you have any questions, please bring them to class and make sure you turn in your notes. Again, have a great night or have a great day.